Hello my dear friends. In the today class, we will discuss about introduction to context-free grammar. In the previous class, we will discuss about the regular grammar. So context-free grammar is a type 2 grammar. In the previous lecture, the type 3 grammar which was regular grammar. So we can say a context-free grammar simply it defines a tuple which contains the four variables. The four variables V, T, P, S, where V stands for variable, T stands for terminal, P stands for production, and S stands for start symbol. And the important thing is that in the context-free grammar or type 2 grammar, the production P are in the form of A produces alpha, where A is known as a variable or it is belongs to the variable, and alpha is a combination of variables and terminals. A is a variables and alpha is a combination of variables and terminals. One important thing we can observe from this, that in the previous example, or we can say in the previous video, in this series, the previous video, the regular grammar contains the form of A alpha A oblique beta, or we can say S is a capital A alpha oblique beta. So these thing and this thing both are two different things. We easily understand the difference between these productions and this production in the next slide with the help of example. So type 2 grammar is also called context-free grammar, we know, and all type 3 grammars are type 2 grammar, but reverse is not possible. It means all regular grammar, or we can say type 3 grammars, are known as a context-free grammar, but the reverse, or we can say context-free grammar, cannot be a regular grammar. The language generated by Type 2 grammar is known as a context-free language, and the machine which accepts the context-free language is called push-down automata. As we discussed in the previous video, this diagram, you know that we will not spend much time on it. So today we are discussing the Type 2 grammar, and Type 2 grammar simply known as a context-free grammar, and context-free Type 2 grammar generate the language which is known as a context-free language, and it accepted by the machine which is known as a push-down automata. Now we have a look and for the example to better understand the context-free grammar. We take an example. The example is that we generate a language, or we can say we generate we want generating the language that generate equal number of A's and equal number of B's in the form of A to the power n, B to the power n, where power are equal. So for generating such grammar, the context free grammar for that particular question is that like this: G is a grammar, it contains the four variable, that is a S, we can say variable, S and A are the variable, A and B are the terminals, it is the production, and it is a start symbol. We derived it production in next video, how it derived and how it looks like. So the one important thing we observe from here, that in the type 3 grammar, or we can say regular grammar, in the regular grammar we can say there is a small a, or we can say terminal, then the variable, or we can say first variable comes then the terminal, but both the cases are not come together. That is the main difference in the type 3 grammar and type 2 grammar. So it is very different, which you can note it down, or if you are not able to understand, then please go my previous video, which is a regular grammar and production of it, and you can also able to distinguish the things between type 2 grammar and type 3 grammar. In the next, for producing such a language where a number of A's and number of B's are equal, first of all, we can say start symbol A produces small a variable capital A and then B. Then this capital A, we can replace this capital A with by the help of small a and B. So we get in the next derivation A capital A, then small b. Again, this capital A, we can also replace it with A capital A and B. So we get triple A and triple B. Again, we can explain A with the same thing, but for sake of simplicity, we just replace A with the help of apps not. We already having the production A generated apps not, it means null string. So we at the end get all the terminals, and the terminals are triple A and triple B. So here we note it down that the number of A's and number of B's in this particular grammars are equal. So number of A's and number of B's are equal in the power of 3. So that is a context-free grammar, and it is an example of context-free grammar. We cannot able to generate this context-free grammar, or we cannot able to generate a finite automata for this particular example. So that is the difference between a finite automata and push-down automata. It are the machine which accept type 2 or type 3 grammar, and the language which is accepted by finite automata is known as a regular grammar, and here the language which is accepted by push-down automata, which is simply known as a, we can say, context-free grammar. So it is our example of context-free grammar, and at the end we can replace a with again repeating like this, then we get a to the power n, b to the power n. So it is a simple example. So now in the next, that is a context-free grammar. So in the next we have a look like properties of context-free grammar. It is simply on the basis of some property. There are some categories. The first category is on the basis of ambiguity, ambiguous and unambiguous. It is a context-free grammar. There are some grammar which is generated in ambiguity. We will discuss in next video. Today we just have a brief introduction to it, or we can say have a look. And another thing is another type is deterministic and non-deterministic. It is also another property. And the last property is left recursive and right recursive context-free grammar. All threes are very important, and we will discuss one by one each everyone in the next video. So thank you very much. If you are having any query related to the same, please ask me in the description box.